Hello guys, Adav is again back here with a new topic. So this is basically under 10 minute series. So in this 10-minute series, I'm actually uploaded the first two topics. The first is motion part, it consists of three parts, and the second one is vectors, which again consists of five parts. So this is again a new topic, which is actually called as motion reversal. This same related to motion, but in a different way. So motion reversal, this is actually the part one. It is actually consisting of three parts. So this is basically the part one I am going to take. This part one is basically consisting of motion reversal. This basically consists of three parts. So in the first part, I am going to take the basics and some sums. In second part, some common misconceptions, and sign convention. This is something I'm going to take in motion reversal. The last part is going to basically be related to a new formula, two new formulas, two new formulas, which is very useful for uh, you know solving sums in very less time, in very less time, right? So this is all the first all of the things. I'm just clear it out. Yes. So now, as I already said in the part one, this is basically the part one. I am going to basically take about motion reversal. So in motion reversal, there is actually a lot of basically in the first part. Please see my videos I have uploaded in the EduBytes channel. In motion reversal, there would be a body which is actually moving in 3 meters per second, and the final velocity will be 5 meters per second, and so in 2 seconds. What will it be? Acceleration, everything, the acceleration will be 1 meters per second square. So this is what we've learned in the first motion topic. Some basics of motion only we have learned. But now in motion reversal, there would be a body starting with some velocity u, having deceleration in this direction, so it would be a, and so it final velocity will be 0 here, and again turn and go like this. So this is basically what is known as motion reversal. The motion of it going in some direction, maybe could be positive direction, again suddenly takes a U-turn and goes in this way. So in fact, we can even solve many problems with this method. So basically, I'm going to teach how to do this. So suppose I can be able to teach only by examples. So suppose a body is being thrown with some velocity u, up, upside, up, is actually being thrown up. So it goes to a velocity, and at one point it becomes 0 meters per second. I already told you about the free fall in the motion chapter, which is there in EduBytes channel. Please follow. Suppose the acceleration is 10 meters per second square, and if you are taking this to be the positive direction, it takes a U-turn because we know 0 meters per second. It takes a U-turn, comes like this, goes in 10 meters per second square. So they may ask questions like what is the distance it covers, and so on. So this is one of the most important things they may ask. So here we can just use many formulas, just like the formula we use, S equals ut plus half at square. That's basically the formula you use here. Suppose they have given the time, we can put the time. A, we know g. A is basically g, which I already told you, which would be maybe 10 meters per second square. That is something very, very important, right? So this is very important. So that's how you actually solve many questions. Upcoming JEE questions are also based on this NEET and JEE. So one thing you have to understand is basically, suppose a body is moving with some velocity, maybe 3 meters per second, having a uniform acceleration a, the body would come to rest here and takes a U-turn and goes here. What would be the velocity here? It's just the same as 3 meters per second. That is one of the main rules, very useful rule. If there is a uniform acceleration, there is a uniform acceleration, then basically here 3 meters per second, if we consider this to be the positive direction, this would be minus 3 meters per second. In this direction, it would be 3 meters per second or minus 3 meters per second. That is how it is. And it also takes an exact time. The time it takes to reach here to here, the time here to here is basically it takes the exact time to reach from here to here. One of the very useful form, way, and we can even solve many questions. So in school, we have actually, we have learned about free falls going like this, coming up and somebody catches the ball here. So let me frame a question. A boy throws a ball with a velocity 3 meters per second. So basically it goes for about, basically 10. So basically we can be able to say that they may ask us to find the time, the total time it takes. Suppose, so if they ask the total time, they may have to given the distance. So basically, this would be 10 meters per second square. Considering this to be the positive, the initial velocity would be minus 3 meters per second using sign convention. So basically, total time from here to here, this would be 0 meters per second, right? So they may ask the distance from here to here also. So if they ask the distance, it's basically we can use the formula 2as equals 1 Yes, 2as equals v square minus u square. So 2, considering that as positive, a would be. So 10, yes. What is v square? 0 minus what is u square? U square is basically minus here. So we don't care minus because square is there. So this is minus 9 by 20. Minus 9 by 20 is, yes, displacement. You may wonder, how can the displacement be in negative? Negative, because we have considered the positive direction to be here. But as the boy throws the ball up here, the displacement from initial to the this distance would be basically 9 by 20. Displacement would be minus 9 by 20. But what about the total displacement of the motion? It is basically this is the total displacement. This is the total displacement. This is also very useful one. Please try to follow this. Very useful for our KE exams. So very useful. This is one thing which I already wanted to say. So we can even carry forward to many motion problems with just 3 equations of motion. So with just 3 equations of motion, we actually know all of that. We have explained in the previous video. V equals U plus AT. S equals UT plus half AT square. 2AS equals V square minus U square. Very important useful formulas. Another very useful thing is average velocity equals V plus U by 2 for uniform acceleration. For UA, I'll just UA, uniform acceleration. And then basically average velocity into time is displacement. This all are already given in the previous motion chapter. So average speed is basically equal to total distance by total time. Average velocity basically equal to total displacement by total time. Very important. Please try to understand all of these. Very useful. So that's all friends. Hope you like this video. So please subscribe to our channel. Subscribe to EduBytes to follow many updates. Please, you can click the bell icon. Try to share so that it motivates me to make many videos. And so this video should be less than 10 minutes, so please try to watch all of these. So thank you friends, hope you enjoyed this video.